Digital.
What if learning informatics could be hands-on, creative, and deeply engaging from the very start? In a classroom in Spain, students cheer as their robot navigates its first obstacle course. They have been designing and programming it in the previous classes, having fun while learning in a practical and collaborative way. Educational robotics refers to the use of programmable robots in the classroom to help students understand key concepts in computing, problem solving, and digital literacy. It's not just about coding, it's about preparing students to thrive in a digital world by encouraging active, applied, and meaningful learning. This approach is especially relevant to the goals of the Digital First Project, a European initiative that promotes a functional approach to teaching informatics in primary and secondary education. The project emphasizes real-world applications, digital fluency, and the development of core competencies through digital tools. The educational robot Robobo, developed by one of our partners, Universidade da Coruña, has been used in schools across Europe to teach not only robotics and artificial intelligence, but also fundamental programming skills. Through years of classroom practice, our colleagues at UDC have discovered how valuable robotics can be as a teaching tool in informatics. With the functional approach proposed by the Digital First Project, this integration becomes both natural and impactful. Educational robotics supports the functional principles of Digital First in the following ways. 1. Informatics as an instrument. Students use robots to solve real-world tasks, like navigating obstacle courses or detecting and sorting objects. This instrumental use develops tangible problem-solving skills. At the same time, learners define how robots should respond to specific events, exercising also the regulatory function by programming actions that influence the environment, mirroring how we manage digital processes in everyday life. 2. Exploring the world. Through sensors such as cameras and microphones, students explore their environment, simulating the heuristic function, learning by inquiry. As they code and create projects that transform sensor data into meaningful outputs, like voice responses or color detection, they also practice a representational function, expressing information through digital means. 3. Teamwork and interactions. While learning, robotics fosters collaboration. Students work in teams to design, build, and program robots, exercising the interactional function. They share roles, exchange ideas, and refine solutions together, developing communication, teamwork, and leadership skills. 4. Imagination and real-world engagement. Robots open the door to creativity. Students can simulate real-life applications, robotic pets that interact with the user in a natural manner, autonomous cars that drive on their own in a safe way, bringing the imaginative function into the classroom. These experiences help students become active creators of technology, not just passive users. In summary, educational robotics aligns perfectly with the Digital First philosophy, empowering students through functional learning, hands-on activities, and real-world problem solving. If you're interested in discovering how the future of informatics education can be transformed through robotics and innovation, stay connected with our channel, website, or newsletter.
Digital.